this video, we're going to talk about complementary counting, and complementary counting is basically this. So, the number of stuff that we want, number wanted, number good plus number bad equals total number. So what that basically means is that we can find the total number of usually we can find the total number of situations quite easily. And then sometimes it's easier to find the number of situations we don't want rather than the number of situations we want. So this kind of method is basically taking the total number of situations, minusing the number of situations we don't want in order to get the number of situations we want. So as an example, I'll move on to problem 6, where Anwar flips 8 coins. He flips 8 coins, or he flips a coin 8 times. And it's asking how many ways can he flip at least 2 heads. So if we're using combinations, we can just say, well, at least 2 heads, how many ways can there be 2 heads out of 8 flips, or 3 heads out of 8 flips, or 4 heads out of 8 flips? So that would be 8 choose 2, so 8 choose 2 heads, or plus 8 choose 3 heads, plus 8 choose 4 heads, 8 choose 5, plus 8 choose 6, plus 8 choose 7, plus 8 choose 8. And I hope you guys can see how solving all this might be a little bit tedious, right? But instead of doing this, and if you guys don't understand why we're using combinations to solve this problem, it's because, well, in this situation, we want to have 2 heads total, right? But we have to choose which 2 coins, and out of all of those 8 coins, are heads, and the rest will be tails, of course. So going by that logic, well, this is how we can figure out how many situations are there where the number of heads is at least 2, but at most 8. Instead of doing that, we can use complementary counting, so we can find the total number of situations, the total, subtracting by the number of situations we don't want, which is 8 choose 1 and 8 choose 2. 8 choose 0. And I'll put this in parentheses. And we can figure out the total number quite easily, right? So out of our coin flips, well, every coin flip there's 2 options. So that'll be 2 options for the first one, then 2 options for the second coin, 2 options for the third, 2 options for the fourth, and so forth. And that is equal to 2 to the 8th power. And then we are subtracting 8 choose 1. Well, 8 choose 1 is 8. And 8 choose 0, as we discussed before in a previous video, is 1. So we have 2 to the 8th power minus 9. And then 2 to the 8th power, well, that's equal to 4 to the 4th power, which is equal to 16 to the 2nd power, which is equal to 259. So 256. 256 minus 9 is equal to 247. And that is our answer, 247. So instead of, adding all the situations where we want, which is quite long, we just found the total, which is 2 to the 8th power, the total number of possible situations, and then we subtract the situations where we don't want, which is 8 choose 1 and 8 choose 0. Because those are the only ways that it would not fulfill our requirement of having at least 2 heads. So that's a taste of complementary counting. Now, problem 7, Felix and Candace are on the same science bowl team. There are 8 competitors on the team. If there are 5 people participating in the astronomy event on the science bowl team, how many different combinations include Felix, Candace, or both? So it's kind of like our committee problem that we did before, where we have 8 people, and and we want to choose 8 of those people to be on the astronomy event, to do the astronomy event. But we have, a few restrictions, and that is they have to include Felix, Candace, or both. So one way we can solve this problem is to find the total number. So 8 choose 5. So this is the total number of situations. And then we can subtract the number of situations that don't have Felix or Candace. So the number of situations don't have Felix and don't have Candace. And then if we subtract that, we will get the number of situations that has Felix, Candace, or both. Well, okay, so if Felix and Candace is out of the group of people, then we have 8 choose 5 minus 6 choose 5. And so, the calculation for that is 8 factorial divided by 8 minus 5 is 3 factorial divided by 5 factorial. That's equal to, 8, 7, 6, 5. Oh, so we're dividing this, so we don't have 5 anymore. And then we're dividing by 3 factorial. 3, 2, 1. This is equal to 6. So that's 56. And 6 choose 5 is 6 factorial divided by 1 factorial divided by 5 factorial. So that's just 6. So, and then we have 56 minus 6, which is equal to 50. So that means that there are 50 different combinations that include Candace, Felix, or both. And the same principle works for complementary counting. We found the total number of situations or different combinations of 5 people that we can get from these 8 people. That's 8 choose 5. Then we found the number of situations where neither Felix nor Candace is on the team. So there are only 6 people that we can choose. And we're rearranging them in those 5 people, groups. And then we get 50. All right, thank you guys for watching. In the next video, we're going to go over another technique called sticks and stones or stars and bars. And then we're going to wrap up this week's lesson. Thank you guys for watching.